I think I'm on. Hi, everybody. My name is Sophie DeBenedetto. Welcome to day 2 of ElixirConf. Glad that y'all could join me. You might recognize me from the huge hit of the Purple Carpet event where we read some highly accurate and very helpful horoscopes. A lot of people have had questions about where that book came from. I will post it on Twitter. A friend of mine gave it to me, but you can get it on Amazon. Anyway, all of that aside, I think we will jump into my talk for you guys today titled It's Alive, Instrumenting Phoenix 1.5 with Telemetry and Live Dashboard. Just a warning, I started out with this one Frankenstein pun and then just veered into cartoons of monsters, so please enjoy. All right, so hi, like I said, I'm Sophie. I'm a senior engineer at GitHub. I'm a maintainer of Elixir School, which is a free open source online Elixir curriculum. And we're always looking for contributors, so check it out. I'm also a co-host along with many other wonderful people of the Elixir Mix podcast, and I'm a graduate of and former teacher at the Flatiron School. You can find me on the internet under mostly my actual name because I'm not terribly creative. Of course, no talk is complete without a picture of my dog. Here he is enjoying the sunshine in a totally normal way. All right, so a little bit of an overview before we jump in. We will discuss telemetry and observability. What are they and what do they have to do with each other? We will build our very own telemetry pipeline, and we'll take a look at telemetry in Phoenix 1.5, followed by a whirlwind, fascinating and thrilling tour of Phoenix and Ecto's out-of-the-box telemetry events. So I want to begin by talking a little bit about telemetry and observability. What are they? What do they have to do with each other? So first off, observability is a word that gets thrown around a lot these days, and I want us to start by taking a step back and asking ourselves, what is it? What is observability? Any one of us who has spent hours or maybe days debugging a production issue that you can't replicate locally, relying on mostly guesswork and institutional knowledge, knows exactly what it costs to lack this ability, the ability to understand what's happening inside a system by examining its output. And a lot of us have actually come to treat this situation as perfectly natural. And I think in the past, it may have been the case that ensuring system observability required a specialized set of skills, but this is increasingly not true of the world we live in today. With third-party tools like Datadog, Splunk, Honeycomb, and libraries like, you guessed it, telemetry, web developers like you and me are empowered to treat observability like the first-class citizen that it really is. So to paraphrase Charity Majors, who is the co-founder of Honeycomb IO, in today's world, we can instrument our code, watch it deploy, and answer the question, is it doing what I expect? In this way, we can build systems that are both understandable and well understood. So Erlang's telemetry gives us visibility, but what is it? Let's take a look. Telemetry is an open source suite of libraries that standardizes how apps on the beam are instrumented and monitored. How does it work? I think a couple quotes pulled from a blog post from Erlang Solution last year really say it best, so I'm just going to go ahead and steal them. At the core of telemetry lies the event. The event indicates that something happened. An HTTP request was accepted, a database query returned a result, a user signed in. And each event can have many handlers attached to it, each performing a specific action when the event is published. And that's pretty much it. An event happens, telemetry knows about it and does a thing. At a high level, it's pretty simple. So let's walk through now how we can roll our own observability pipeline in our Elixir apps using the telemetry library. In order to use telemetry in our Elixir app, we will attach the event to a handler, we'll execute the event, and then we'll handle the event. Let's dig into each of these 3 steps now, beginning with attaching the event to a handler. So what does it mean to attach an event to a handler? One thing that really surprised me when I first dug into telemetry and looked through some source code, although we often use the publish subscribe language to describe telemetry events, like you might say that an event was published or sent, telemetry doesn't rely on gem servers or message passing of any kind between processes to execute and handle events. Instead, it leverages ETS or ETS, Erlang term storage, Erlang's in-memory store. So attaching an event to a handler really just means that we're storing the event name in an ETS table along with a handler function for that event. And we do this with the telemetry attach for function. This stores the event and handler in the ETS table, and we'll take a look at an example now. So let's say I have a Phoenix app called Quantum. Get it? Quantum, measuring things. I guess I'm a little bit creative. So I've got my Quantum app and I want to execute and respond to a telemetry event every time my app receives a web request. I'll need to attach the event to a handler, i.e. store the event name in S with the handler function, and I'll need to make sure that this happened when the app starts up. So we'll want to call the attach for function in our application start function. And let's actually take a look at that now. I am just going to full screen this so that you guys don't have to see my many tabs. Excellent. All right, taking a look at that application start function. So we are calling telemetry attach here, and we're passing it the event name. And in our case, I've decided we'll name our event Phoenix request, nothing too fancy. We are also passing it the handler function that we want to call later on when that event is executed. I want telemetry to execute the handle event for function defined in my very own quantum telemetry metrics module, which we'll take a look at later on. So now that we've attached an event to our handler, let's take a look at event execution. Events are executed via a call to telemetry execute 3. Telemetry execute 3 is called with the arguments of the event name, some measurements, and metadata. What happens under the hood? Under the hood, it looks up the event in ETS and it calls the stored handler function. So revisiting the Phoenix request event that we attached to our handler earlier, let's say we want to execute our event from a controller action to indicate that our app has processed a web request. We will hook into that controller action and we'll call telemetry execute with the event name. The event measurement map, in our case, we've captured the duration of the request. How long did it take our controller action to finish processing this request? And we're also passing in some event metadata. Here we're using the connection object, which we know has a lot of nice, helpful metadata in it. All right, now that we know how to execute our event and we know how to attach our event to a handler, let's make sure we can handle that event. Let's define the handler module and function that we stored in F. So recall that we attached a handler to our event, quantum telemetry metrics handle event 4. We're going to go ahead and define that now. So the handler function expects to be called with the event name, measurement, and metadata. Here we've implemented our handler module and the function matching the function that we're storing in X. And we have implemented handle event 4, expecting to receive the event name, the event measurement map, and the event metadata. And we can see that our handler module isn't doing anything too fancy. We're just logging out some information about the telemetry event, but you could imagine doing lots of helpful things in your handler functions. Logging, sending information to statsd, Datadog, Prometheus, you name it. So we did it, and that was so easy, sort of. I think it was too much work. So what did we have to do here? We had to define the handler module and the function. We had to manually attach the event to the handler with a call to telemetry attach 4. We had to manually execute the event with a call to telemetry execute 3. And on top of that, the more events we want to observe, the more work we need to do. So this approach doesn't quite scale. Wouldn't it be nice if we didn't have to do basically any of this? If only there was some abstraction around the attaching, execution, and handling of commonly observed events that we could opt into. So luckily, Phoenix 1.5 provides exactly this for us with the incorporation of the telemetry metrics module, as well as some out-of-the-box telemetry events executed directly from Phoenix and Ecto. All right, let's take a look at how telemetry is baked into Phoenix 1.5. Here's what we're going to cover in this section. We'll talk about some basics of telemetry in Phoenix 1.5. We'll drill down into the telemetry metrics module, and we'll look at exactly how we can use it to measure these telemetry events. And then we'll move on to something that I am really excited to talk about, which is LiveDashboard as a telemetry reporter. Let's get started with some basics. So as I mentioned earlier, Phoenix and Ecto execute some telemetry events for us for free right out of the box. There are events describing web requests, database queries, you get the idea. This actually isn't new to Phoenix 1.5 or recent Ecto releases, but Phoenix 1.5 now provides new out-of-the-box ways of responding to these telemetry events. Whereas before you had to roll your own telemetry implementations just like we did in the previous part of this talk. We would have had to attach events to handlers ourselves, define our own handlers, and so on. So we're going to take a closer look at some of these out-of-the-box events later on, but first I want to talk about the telemetry metrics module and how it allows us to measure and report on events. So Phoenix 1.5 ships with its own telemetry metrics module, and this is where we will define which telemetry events we want to handle and how. It abstracts away the need to manually define your own event handlers and attach those events to handlers. The telemetry metrics module is responsible for measuring telemetry events and reporting them to a telemetry reporter for you. The telemetry reporter implements the event handler functions, and it's responsible for attaching the events to the handlers when the app starts up. You don't have to call attach anymore, which I think is a win. The reporter goes on to handle events when they are executed, and this reporter could be some module or utility that reports your events and metrics to the console, to StatsD, to Prometheus, or drumroll please, LiveDashboard. So LiveDashboard, as you may know from some of the talks that have already been going on this year at ElixirConf, it's a library that integrates into your Phoenix web app and provides real-time performance monitoring and debugging tools for Phoenix developers just like you. Here's a look at Elixir Company's live dashboard. It's probably changed since I took this screenshot, actually. Elixir Company, if you don't know, is an open source project that lists companies using Elixir, post job openings, stuff like that. We exposed our live dashboard behind auth, but you can auth in with your GitHub accounts. You can go in and poke around with the Elixir Company live dashboard if you're interested. Live dashboard has a lot of powerful observability chops, but today we're just going to focus on the manner in which it reports and visualizes telemetry metrics. So here we see a visualization of the Phoenix router dispatch stop event. That's kind of a mouthful. And this visualization graphs the duration of the web request that our app has received. We're going to take a closer look now at how this telemetry event is executed and handled by Phoenix 1.5 and LiveDashboard. And the key to this capability is, you guessed it, the telemetry metrics library. So let's measure this event with our telemetry metrics module. We're going to trace the lifecycle of this event, and it's executed for us for free by Phoenix. We'll take a look at how Phoenix executes the event, how we can configure our telemetry metrics module to measure it, and how we can report it to LiveDashboard for handling. All right, so the Phoenix router event that we are going to be observing here. I want to start by taking a look at how and where Phoenix executes the event. So you might recall that earlier we created our own web request telemetry event. I think we called it Phoenix router. I don't remember. You remember. We created our own web request telemetry event, and we executed it manually from our own web apps controller action. And we've already identified that this is too much work. We certainly wouldn't want to be responsible for executing this telemetry event from every controller action in our entire app as it grows. Too much work, doesn't scale, too much duplication. We don't love it. Luckily for us, Phoenix source code executes a telemetry event for every single incoming web request for you for free when that web request is done being processed successfully. So here we see in the Phoenix router module, telemetry's execute function is called with the event name of Phoenix router dispatch stop, a measurement payload that describes the request duration, and a metadata map including the connection information. Phoenix 1.5 out-of-the-box metrics module measures telemetry event occurrence by mapping, in our case, the Phoenix router event and other Phoenix and Ecto events to specific metrics. These metrics teach the telemetry reporter how to aggregate, format, and report on the event. So for example, should it treat it as a counter metric that tracks the sum of event occurrences over time? You could say, hey, treat it as a gauge measurement, which measures the value of an event at a given point in time. Here's a look at the telemetry metrics module that now ships with any new Phoenix 1.5 app. So all of this code was generated for us for free when we generated our new Phoenix app. And we see here that we've got our quantum telemetry module. It's importing the telemetry metrics module, and it implements a metric 0 function, which in turn uses the telemetry metrics functions, another kind of mouthful. Here we see two examples, the counter and the summary functions. And these functions specify which telemetry events to treat as which kinds of metrics. We're going to take a closer look at these now. Okay, so starting with the summary function, this is going to tell the reporter to calculate the statistic of the selected measurement for the Phoenix router dispatch stop event, the duration of that over time, so max, mean, percentile, etc. We've also got the counter function, which tells the reporter to treat the event as a count metric, which is a total sum of the given event. So each of these functions takes in an argument of the telemetry event name. Here we see Phoenix router dispatch stop, and returns a properly structured metric definition. The metric definitions implemented here in our metric 0 function are going to be used later by whichever telemetry reporter you choose to use. For example, the StatsD reporter would format the metric and send it to the StatsD agent, which would aggregate it appropriately, while the LiveDashboard reporter will aggregate and format the metric and use it to update the dashboard UI. This actually brings us pretty perfectly to the final step of our telemetry pipeline, which is handling the event. And our next topic, the one that I am the most excited about, LiveDashboard as a telemetry reporter. So LiveDashboard stores our telemetry events in ETS along with their metrics definition and its own handler function. Later, when a telemetry event is executed by Phoenix source code, for example, LiveDashboard's telemetry event handler function is invoked. This tells LiveDashboard to update the UI in real time. And it does all of this for free. So just to highlight what LiveDashboard does for us, we define our telemetry event in that metrics module that gets generated with our app. We give these events as metrics to LiveDashboard, and then we're done. LiveDashboard stores the events and the metrics definition in ETS with its own handler. LiveDashboard will handle the events later when they're executed. So now I want to take a closer look at how LiveDashboard does all of that great stuff for us. We are going to cover how LiveDashboard attaches events, how it handles events, and then we'll take a step back and we'll put it all together. How LiveDashboard attaches events. So the following slide is the only LiveDashboard code we have to write. Any other subsequent code examples are all LiveDashboard source code. And I want to call that out here to highlight like just how little work we have to do, just how much heavy lifting LiveDashboard does for us. So the only thing we're responsible for is mounting the LiveDashboard route in our app's router and providing the name of our app's telemetry metrics module. Here in our router, we mount the LiveDashboard route with a call to the LiveDashboard macro and an argument of our metrics module. And this is where all the magic happens. It kicks off the process of attaching events to handlers. The LiveDashboard macro maps the dashboard's metrics route to a live view. So this is what's going on under the hood in this macro. We are mapping the metrics route to the metrics live view. And when it does this, it passes the metrics defined in our metrics module to that live view. So here, ops is the return of calling, in our case, quantum telemetry metric 0, which I've omitted here. So now when the metrics live view starts, it's going to attach our telemetry events with these metrics definitions to its own handler. And it does this by calling on another module under the hood of LiveDashboard, telemetry listener listen to. So in the metrics live mount function, we see that it invokes telemetry listener listen to, passes in our metrics definitions, and that's there as an argument, which we can see right here, metrics definitions passed in, trickle down via our call to LiveDashboard in the router. What does this do? This iterates over the events and the metrics definitions, and it calls telemetry attach for each event. So here we can see the init function of the telemetry listener, and we see that it's calling telemetry attach for with the event name here, the metrics definitions here. Also the PID that references the metrics live view, and we'll see why that's important in a little bit. And lastly, its own handler function, the handle metrics for function. So later, when the telemetry event is executed, this is the function that will be invoked. So let's talk about that event handling now. Events are handles, as we've just seen with the telemetry listener's handle metrics for function. What does this do? It formats event measurements according to the metrics definitions that we stored in ETS. So here's some fancy work to do some metric measurement evaluation and formatting. We're not going to get too into that. Then what does it do? It reports these measurements to the metrics live for a UI update. And here's where that metrics live PID that we stored in ETS comes in handy. We're going to use it to send these telemetry measurements back up to the live view. Metrics live view knows how to respond to this message, having implemented a handle info 2 for it. And what does it do in this function? It handles this update by updating the chart component state. We can see here via a call to send update to the chart component. This triggers a UI change, and we'll see it rendered here back on our dashboard in real time. Pretty cool, but that was a lot. So we're going to take a step back and put it all together. All right, so telemetry metrics metric 0 function maps telemetry events to metrics. We pass these metrics definitions to LiveDashboard in the router. LiveDashboard starts up the metrics live with these metrics definitions. Metrics live is responsible for calling telemetry attach to store the event names, metrics, and handler in ETS, so that later when a telemetry event is executed, telemetry calls the stored LiveDashboard handler, which formats the event metrics, sends a message back up to the live view, which updates state and triggers a UI change. We did it. All these monsters are so happy for us. And my dog's really happy for us too. Actually, he's really happy about sticks, which are his favorite thing. But he's also exhausted, and so are we. That was a lot of information. So it's time to take it home. Telemetry is a powerful tool. It gives us visibility into our Elixir application. It allows us to measure and monitor how our app is performing and behaving. It makes observability the first-class citizen that it really is by building it right into the framework of Phoenix and Ecto. Telemetry exposes the output of our system so that we can understand what is going on inside it. So now that we understand how great and amazing telemetry is, I want to take a brief look at some of the useful events that Phoenix and Ecto execute for us for free right out of the box. And I think in doing so, we'll see what telemetry gives us the ability to measure and know about our system. All right, so Phoenix and Ecto's telemetry events. Start with a brief look. This is totally not comprehensive, just a brief look at some Phoenix telemetry events. So here's the event that we used in our example today. We already saw how the Phoenix router module executes this event after the request is processed successfully by the plug pipeline and the controller, but before a response is rendered. And we see it's executed with duration and metadata. We also have this helpful error rendered event that's going to get executed by Phoenix endpoints render errors module. Phoenix also provides some instrumentation for socket and channel interactions. The Phoenix socket module executes a telemetry event when the socket is connected to. And here metadata contains info like the endpoint, params, user socket, connection result, helpful stuff like that. We can also see the Phoenix channel server executing some telemetry events. It's going to execute one when the channel is joined, and also one whenever the channel invokes handle and to. Here, duration would describe the duration of the channel join function, like how long did it take to go from receiving the channel join request to concluding it. Something I'm really excited about, we have some shiny new, I think this was just merged into live view like maybe a month ago at this point, a little bit longer, new live view telemetry events. So there's a bunch of live view events that get executed. We're just going to take a look at a few of them. We've got the mount, start, stop, and I believe exception event. So these are all executed to give us some instrumentation and some visibility into the behavior of our mount function. I think we also get a start, stop, and executed for handle event, which is great. Exception rather. So a theme should be emerging, right? For any occurrence that we might care to instrument, a really good idea for what to kind of get out of that event would be a start, stop, and exception telemetry event. So a lot of libraries you're going to be peeking into, whether it's LiveView or Phoenix itself, you'll see these telemetry events executed, a start, a stop, and an exception if an exception is raised. If you're instrumenting your own telemetry events, like let's say you are a library author and you would like to get some telemetry events out of it so that your users can gain some visibility, but you're not thrilled about having to execute 3 telemetry events every time you want to tell the world that something happened, you can look into the telemetry span 3 function, which abstracts this away for you. I think that's a recent inclusion into telemetry, I think with the help of one of our Elixir Mix co-hosts, Alex Koutmos, and if it is him, then thank you, Alex. And if it's not him, sorry to whoever I've stolen the credit from. All right, taking a look at some Ecto telemetry events. So just one event that I want to take a look at, the repo query event. So Ecto is going to execute this event for every query sent to the Ecto adapter, and it will execute the event with a measurement map and a metadata map. There's a ton of information that gets put into the measurement map, but I just want to call out one data point. The total time key describes the total time our app took to execute an Ecto query and return some results. Ditto for the metadata map, ton of info gets put in here. I just want to call out a few data points that help us observe our app's querying behavior at a granular level. With this information, we can see how many queries of which type are executed against a given resource, how long those queries took, and so much more. So we can implement metrics for any of these events and more in our telemetry metrics module, which if you recall is the place where we say, hey, these are the telemetry events I care about, please measure them in this way. So before we completely wrap up, I promise we're almost there. Let's take a look at how we can do exactly this with one of our Ecto repo events, this repo query event that we were just looking at. In this example, we are going to see how we can leverage telemetry's tagging options to get the most information out of our telemetry events when they are handled and reported. All right, so every telemetry metrics function, in our case, we're looking at the counter function here, supports the tags and tags values options. We can use the tag values option to store a function that will be called later on during event handling to construct additional tags from the metadata map. And then we use the tag option to specify the complete list of tags to be returned from the tag values function. So last thing we have to do is implement this tag values function that expects to receive the event metadata and return a map that includes all the tags we want to apply to our metric. So what does this mean? Let's take a look at it in action. Let's say that the following query is executed in our app. From you in users where age is greater than 18, select name. This is the metric that we would report having applied our tags. This is pictured here using the stats-D reporting format because it takes great advantage of tags and it's super clear how those tags are applied. The utility of tags is kind of depends on what reporter you're using. Stats-D is pretty common and you can get it working pretty nicely with some information-rich tags right out of the box with telemetry. So tags are great. They allow us to measure and aggregate information-rich events. And we can use tags to measure failed and successful web requests by endpoint, Ecto queries by resource and query type, and much more. In this way, telemetry allows us to build rich observability directly into our applications. It really empowers us as web developers. With the native telemetry events executed by Phoenix, we get visibility into the behavior of our web app. We can measure and report on things like average request times. We can identify slow endpoints. We can see when and where errors are spiking and why. And the shiny new live view telemetry events allow us to gain the same kind of visibility that we're used to seeing for web requests now for our WebSocket powered live views. Meanwhile, we have these Ecto events that allow us to measure query times, identify slow and expensive queries, and so much more. All of this illustrates just how powerful a tool telemetry is in our observability toolbox. Thank you very much. One last dog picture, terrifying monster. It's so weird. And some resources that I definitely encourage you guys to check out. I'll make these slides available later on, some posts from Elixir School, and also a great recent post from Chris Keithley on telemetry convention. So you'll learn more about span and some other tips and tricks there. And thank you. I'm actually not totally sure if I have time for questions. Maybe someone can let me know in the chat. I do see the questions that have come through. And so, oh, I do have time for questions. Fantastic. Let's open some questions. Great. Does any of this integrate with New Relic? Might be a question more for the New Relic adapter authors. Yeah, great question. So I would say that the answer is definitely yes. Telemetry is really flexible in that it totally decouples your event execution from how you want to handle and report on those events. So if you recall our sort of DIY hand-rolled example from the first part of the talk, we built a telemetry metrics handler, a reporter, and the only thing that that reporter did was just log something. But that would be a great place to put your New Relic adapter code. That would be a great place to say, great, I received this telemetry event. I'm going to forward it to New Relic in that way. All right, let's see. How heavy could be the telemetry data to send when we are sending to an external component, Sentry, Prometheus, et cetera? Yeah, I mean, again, it's really up to you what data you're going to send along to Sentry, Prometheus, stats-D, agent, whatever. All of that is the responsibility of your telemetry event handlers or reporters, and writing that code is entirely up to you. So if you're used to, capturing an exception and sending it along to Sentry, let's say, you would just move that responsibility into your telemetry reporter or event handler. How does a live dashboard work in a clustered environment for telemetry, i.e. behind a load balancer of 3 to 4 replicas? I'll do my best to answer this question from what I understand you're asking. So live dashboard allows you to select the node that you're looking at if you are, clustering your application. So if you pull up the live dashboard, you could look at it in Elixir Company, you could look at it in any of your own apps, you can select the node that you're viewing statistics from. I'm not sure what capabilities it has to kind of sum up metrics across nodes, though. That's a great question. And if anybody out there knows, definitely hit us up on Twitter. All right, I think that's it for questions. I think that's it for me. So I'm just going to pause, make sure that we're ready to wrap up before I do. Great. Yeah. Thank you all so much. If you have further questions, find me on Twitter. And I think that's it. Thank you.